Good day everyone, my name is Mouleesh from Group 3. I am the leader of Group 3 and today my team members and I would like to present about the thermochemistry of hot packs and cold packs. First and foremost, I would like to introduce my team members to all of you.
Hi, I'm Ashveen from FIS July 2022 intake.
Hi everyone, my name is Tong. I'm from Foundation in Science intake of July 2022.
Hey everyone, my name is Yuga.
Hi, hello, I'm Hema.
Hi, I'm Vivian. I'm from Foundation in Science July intake.
Hi, my name is Yi, and I'm from Foundation in Science July 2022 intake.
Hi, my name is Sherry Lee.
Hello, my name is Kawai from FIS July intake.
Hi, my name is Hema.
Okay, good morning. So, my name is Inesh and I'm from FIS, SEM 2.
So what is our problem? So based on my team members, our problem statement is to identify the principles of thermochemistry activity of instant hot packs and cold packs. So what is thermochemistry? Thermochemistry is a branch of chemistry that involves heat. So basically thermochemistry is separated into two. First part is thermo, which means heat, while chemistry is the study of molecules and reactions. So thermochemistry means the study of heat, or you can say the heat of chemistry. Thermochemistry is the branch of thermodynamics that deals with the heat absorbed or produced by a chemical reaction. A reaction either can be exothermic, or which is the release of energy, or endothermic, which is the absorption of energy. This change in energy is normally represented by a delta. And now I'm going to pass to Ashveen, who is going to explain to you guys what is exothermic and endothermic reaction.
I will now move on to explain about exothermic and endothermic reactions. Starting off with exothermic reaction. The main concept that we should be aware of is thermal energy is released to the surrounding. So this means that the temperature of the surrounding will increase. The energy change is also said to be negative because energy is transferred from the chemical system to the surrounding. So the energy of that system falls, which is why it is negative. The overall transfer of energy is also from the system to the surrounding. So now I will give an example for us to better understand the term system and surrounding. So let's say we are dissolving salt in water in a container. The salt and water will be the system and the container will be the surrounding. Not only that, but bonds are also formed in an exothermic reaction. The formation of bonds actually helps to improve the stability of the reaction. For example, hydrogen atom reacts with oxygen atom to give us water, which is helped by covalent bonds. Next is endothermic reaction. For this type of reaction, thermal energy is absorbed from the surrounding, so the temperature of the surrounding will decrease. The energy change is also said to be positive because energy is transferred to the chemical system. So the energy of that system rises, which is why it is positive. The overall transfer of energy is also from the surrounding to the system. Apart from that, bonds are also broken in an endothermic reaction. This is because the energy absorbed is able to overcome the attractive forces between the atoms. For example, when hydrochloric acid absorbs energy, it will be broken down into hydrogen and chlorine. Moving on, this is a graph that I've drawn for exothermic reaction. The x-axis represents the reaction progress and the y-axis shows the energy of the reactants and the products. The difference in energy between the reactants and the product is the energy released, as you can see represented by the arrow in red. Whereas the arrow in blue shows the activation energy, which is measured from the peak of the curve to the reactants. So what is actually activation energy? It is the minimum amount of energy needed for colliding molecules to react in a chemical reaction. A chemical reaction can only take place if this activation energy is achieved. Another thing that we can observe from this graph is the energy of the products is lower than that of the reactants because energy is released in an exothermic reaction. As for the endothermic reaction graph, the energy difference between the reactants and the product is the energy absorbed, as you can see represented by the arrow in red. Another component that differs the endothermic graph from the exothermic graph is the energy of the products is higher than that of the reactants. This is because energy is absorbed in an endothermic reaction. One of the ways of how we can reduce the activation energy is with the presence of a catalyst. So a catalyst is divided into two categories, namely a positive catalyst and a negative catalyst. However, for this presentation, I'll be focusing on a positive catalyst. So a positive catalyst is actually a substance that increases the rate of reaction. For example, we have vanadium oxide that acts as a catalyst for the contact process in the manufacture of sulfuric acid. Bear in mind that a catalyst only alters the rate of reaction, but it does not increase the amount of products formed. That's all from me, and now I will pass on the presentation to Tong. Thank you.
For my part, I'm going to talk and explain about enthalpy. First of all, what is enthalpy? In a thermodynamic system, the measurement of energy is known as enthalpy, which its quantity can equal to the total content of a system heat. There is a formula for the enthalpy, which is H equals to E plus PV, which H is the enthalpy, E is the internal energy of a thermodynamic system, P is the pressure, and V is for the volume. Based on the formula of the enthalpy, we can define enthalpy as the sum of the internal energy with the product of the pressure and volume. There are two types of enthalpy that I'm going to explain, which is the enthalpy of fusion and enthalpy of vaporization. And these two types of enthalpy are also known as the latent heat of fusion and latent heat of vaporization. The first type of enthalpy of fusion. This enthalpy of fusion is the energy which is required for a substance to change the phase from its original state, which is the solid state, to the state of the liquid. While the second type of the enthalpy of vaporization, it is the energy which is required for a substance to change the phase from its liquid state to the state of the gas. At the same time, there is a relationship between the change of the enthalpy and the flow of heat. Before I explain about it, I would like to let you know what is the change of enthalpy. The differences between the energy which is used to break the bond of a substance in a chemical reaction and the energy which is gained by the formation of a new chemical bonds in the reaction is known as enthalpy change. When linked the change of enthalpy and the flow of the heat together, a formula is formed, which is the delta H equals to Q if there is a constant pressure. Therefore, when an endothermic reaction happens, if the value of Q get is negative, the value of the change of enthalpy also will be negative. When an exothermic reaction happens, the value of change of enthalpy will be positive, since the value of Q get is positive. That's all for my explanation of enthalpy. And for now, I would like to pass the floor to Yuga to continue with the topic of calorimeter.
And I would like to present about calorimetry. Basically, in chemistry and thermodynamics, calorimetry is the science or act of measuring changes in state of variables of body of the purpose of deriving the heat transfer associated with change of its state due, for example, to chemical reaction, physical reaction changes, or phase transition under specific concentration. Moreover, calorimetry is the accurate and precise measurement of heat flow for chemical and physical processes. It operates the law of concentration for energy. What is that? In a simple way, heat loss the same amount of heat gain. A device used to measure the absorption or release heat called calorimeter. Basically, for the experiment of calorimetry, the device used is a calorimeter. Moreover, the enthalpy change associated with the chemical reaction, processor, and the specific heat of constant. And now I'm going to talk about formula of calorimetry. The heat transfer is proportionally to the mass of the object, specific heat capacity, temperature change, and heat as the temperature symbol as Q, and is calculated using Q equals to m theta temperature calorimetry, the mean specific heat capacity. Does anyone know how calorimeter works? Let me explain. The temperature of liquid changes when it loses or gains energy. Moreover, they measure the mass of the liquid along with the temperature to determine the amount of the energy changes. Last but not the least, it differs from a thermal analysis in that thermal analyzer, what analyzer measures the properties of a material at a various temperature. Basically, temperature plays a very important role in this experiment in a two reaction, endothermic and exothermic. That's all. And now the next slide will be presented by Hema about heat and thermal energy. Thank you.
And I'm going to talk about heat and thermal energy and how does it works. First of all, we need to know the definition of heat. Heat is the form of the energy that flows from one object to the another object, and also is a form of energy that's in the process of getting transferred from one object to another object. And also, it is a thermal energy moving from a warmer object to a cooler object. And meanwhile, for the thermal energy is a reflection of the random motion of the molecules in an object, and also is a form of energy that remains stored in the system as the kinetic energy. The difference between thermal and heat energy is thermal energy gives the total kinetic energy in the system process, and it is used to determine the internal energy of such system. In a system, it increases with increases in temperature. Hence, there would be the greatest speed in the molecular motion in the system. Meanwhile, for heat energy, is the flow of the thermal energy between two objects of different temperature, whereas the thermal energy tells about how is the transfer of energy due to the temperature difference between two bodies. And let's move on to the types of thermal energy. There are three types of thermal energy. which is radiation, conduction, and convection. Radiation is the energy that comes out of a radioactive atom, and conduction is the process by which heat energy is transmitted through collisions between neighboring atoms or molecules. Meanwhile, and the last one is the convection. Convection is the process of heat transferred by the bulk movement of molecules within fluids such as gases and the liquids. And the last one is the formula that given. The formula that given for the thermal energy is Q equals to mc theta. Q is represent for the thermal energy, and M is the given substance mass. C is specific heat, and the data is difference in temperature. And I would like to pass this to Vivian. Thank you.
Now I'm going to talk about the instant ice pack and instant hot pack, which can be seen in the trigger picture. For instant ice pack, there are many possible chemicals that can be found inside an instant ice pack. But mostly it can be found containing water and ammonium nitrate. Some other possible chemicals that can be found are potassium nitrate or sodium thiosulfate. For instant hot pack, it mostly contains water and magnesium sulfate or calcium chloride. It can also be found containing wet iron powder, sodium chloride, or calcium oxide. For instant ice pack, it undergoes an endothermic reaction, whereas for instant hot pack, it undergoes an exothermic reaction. Similar processes take place between both of these reactions. When the salt dissolves in water, the ionic bonds of the salt will be broken down. This process needs energy that is obtained from the surrounding. The ions then form bonds with the water, which then releases the energy to the surrounding. Hence, if more energy is absorbed than released, then the process is an endothermic reaction, which causes a decrease in the temperature of the instant ice pack that is noticeable by touch. However, if there are more energy released than absorbed, then the process is an exothermic reaction, which causes the instant hot pack to feel warmer. Now I'm going to talk about the functions of both instant ice pack and instant hot pack. For instant ice pack, it helps to remove heat from the inflamed body organs or tissue. It can also be used to reduce the swelling of the wounds by absorbing the heat from the wounds. It can also be used to reduce the lumen size of the blood capillaries to decrease the rate of this blood circulation, and this can help to stop bleeding. Next, it can also be used to relieve muscle or joint sprain, relieve fever, and is usually found in the first aid kit. Next, I'm going to talk about the function of instant hot pack. Instant hot pack can be used as a hand warmer to keep us warm during any cold weather. It can also use to relieve our muscle cramps. Next, it can use to increase the lumen size of the blood capillaries, which can help to increase the rate of the blood circulation, and this can help to deliver more nutrients and oxygen to the injured area to promote healing. And lastly, it can be used as a self-heating packaging, which is shown in the picture below. Last but not least, from the trigger picture, we can see a single-use only label. This indicates that the instant ice pack and instant hot pack cannot be used to initiate another reaction again once the reaction has been finished. That's all from me, and now I'm going to pass it to Inesh to talk about the instructions on how to use an instant ice pack and instant hot pack.
Okay, I would like to explain on how to use hot and cold packs. So as you all know, hot cold packs give relief to chronic pain and helps off muscles relax. The heat pack or heat therapy, first you need to microwave the pad for at least 45 seconds and letting it sit for an additional 30 seconds before applying the skin. This is so that you don't burn your skin. and it won't be so hot, and it will help you relax rather than giving you pain. So if you need a hotter pad, if you desire a hotter pad, I can microwave for additional 54 seconds. That's the maximum. If you want extra hotter, you can add in more seconds, but make sure it doesn't burn your skin. If it does that, your skin might be more pain lah. Okay. So next is cold pack. So as you all to use the cold pack, there's like a substance inside. It's like ammonium nitrate or calcium sulfate. So to activate the contents, you must shake the contents to the bottom of the bag. And you must locate the inner fluid pouch and squeeze firmly to rupture. So you shake briefly to mix the contents and wrap in a soft cloth and towel to apply. So the instant cold packs are perfect for quick efficient pain relief and can be disposed after treatment. So it's important that it's a major fact that you have to leave it in the fridge. Some cold packs are applicable. You can leave it in the fridge for a long time. So therefore the cold pack will be cold and immediately be used. Here for certain cases. But in this case, you want a quick relief, you have to use the content cold pack. When you do shake the content stuff and all the instructions I just stated, it will be a quick relief, as I said. You can be used in sports. For example, you playing sport and immediately you can use this particular cold pack. Same goes to the hot.
Now, I'm going to talk about the other example of endothermic and exothermic reaction. As we can know that endothermic reaction is a chemical reaction that absorbs heat from the surrounding. From this definition, we can think about the example of this reaction that may be happen in our daily life. First of all, the process from the nature that's easily to be seen in photosynthesis. The green plant absorbs light energy and convert carbon dioxide and water into glucose and oxygen. So, this is considered as an endothermic reaction. Besides, the other example is the melting of ice. Same theory with the endothermic reaction, the ice will absorb heat energy from the surrounding to break the hydrogen bond. Then, the ice changes from solid state to liquid state. Next, evaporation is also an example of exothermic reaction. Evaporation is a process that changes a liquid to a gas. The liquid absorbs heat from the surrounding, and the particle inside move faster because the kinetic energy increases. When the particle absorbs enough energy to overcome the vapor pressure, it will escape and enter the surrounding of air as a gas. Besides the example of endothermic reaction, there are also some other examples of exothermic reaction. If we recall back, exothermic reaction is a chemical reaction that releases heat to the surrounding. From this meaning, we can know the first example of the exothermic reaction in our daily life, that is firework. During the burning process, the heat energy is released to the surrounding in a short period of time. So this actually can be considered as small explosion that can produce the various type of colors. Next, respiration also is an example of exothermic reaction. During respiration, carbohydrates that is present in food are broken down to form glucose. Glucose combines with oxygen in the cells of our body and provides energy. Then, the other example is ice formation. When a liquid turns its state to solid state, which means water becomes ice, heat energy is released to the surrounding. When heat energy is released, the particle inside the liquid moves slower because the kinetic energy decreases. Thus, the particles become closely packed to each other and finally form solid. In addition, rusting is considered as an exothermic reaction. The rusting process is the process of oxidation of metal ion with the presence of oxygen and water. This process will release a lot of heat. This is all from my part. Now, I will pass it to Sherry for the presentation of precaution when using hot pack and cold pack.
And I'm going to be explaining about the precaution and safety tips when using an instant hot or cold pack. Both precautions of the hot and cold pack are basically the same, such as we should not use the instant hot or cold pack for no longer than 20 minutes at a time and wait for 1 hour between each treatment. Second precaution, we should remove it immediately when using it if our skin appears to be in a pinkish or reddish condition. Third precaution, if our skin or eye is in contact with the content of the hot or cold pack, we should wash it with clean water immediately because the content is very toxic. Fourth precaution, anyone with a heart condition or high blood pressure should consult with a doctor before using. Fifth precaution, avoid using hot or cold pack on areas where you have skin infection, swelling, bruising, contusions, or an open wound, as using it further may cause even more damage. Sixth precaution, avoid using a hot or cold pack if you have limited feeling on skin due to nerve damage, as it may cause even more damage to our nerves. Seventh precaution, never fall asleep when using hot or cold pack. Eighth precaution, we should wrap the hot pack or cold pack with a thin towel when applying to avoid a too high temperature, as if it's too high temperature or too low temperature, it may cause more damage to our skin. Lastly, I'm going to be explaining about the precautions after using a hot or cold pack. We should not drain the contents of a hot or cold pack down the drain, toilet, or sink to prevent clogging. And after using it, we should double bag it and tie it tightly before disposing in the garbage bin. Thank you. And now I'll pass it to Gawai to talk about the negative side effects.
Now I'm going to talk about the side effects of using instant hot packs and instant cold packs. Despite the usefulness of instant hot packs and cold packs, they also come with some side effects due to the fact that it introduces temperatures that are abnormal to the body. For instant hot packs, mild skin burns and redness are the more common side effects. However, these effects last only for a short while and it goes away after some time of the removal of the hot pack. Instant hot packs can also increase swellings and inflammation. This is because the heat promotes blood flow to the applied area. Effects like skin burns will intensify if hot packs are applied directly to skin or continuous use for too long a time. Moreover, improper usage might also cause abscesses. If the hot pack is applied to infected wounds, the infection is very likely to spread and will worsen the infection. One might also experience a decrease in blood pressure and increase in heart rate after using instant hot packs. This is because the heat from hot packs can induce dilation of blood vessels, therefore allowing more blood to flow. Because of that, the heart will have to work faster to keep up with the increased blood flow to the heated spot. However, once the treatment has stopped, blood pressure and heart rate will return to normal eventually. Instant cold packs will usually cause temporary side effects such as mild skin burns, numbness, redness, and skin irritation. Depending on how cold the hot pack can be, if it is used directly without covering or used for a prolonged period of time, frostbite might occur which can cause permanent damage. Besides that, when in contact with extreme coldness, skin tissues will be damaged as they are not able to withstand the extremely low temperature. This will result in an ice burn. Long-term coldness can also cause nerve pain. Muscles at the applied area can also be temporarily slowed down or inhibited, reducing motor function for a short period. As temperature increases and is returning to normal, muscles and nerves will become active again. Rare cases of hives on skin would happen as an allergic reaction for people who have cold urticaria using cold packs for a few minutes. For your info, cold urticaria is a condition of being allergic to cold. Although there are many possible side effects of using instant hot packs and instant cold packs, most of the side effects can be mitigated if they are used properly, following the precautions. When under normal usage, unless there are certain complications, the side effects of using instant hot packs and cold packs are usually close to none. Now I'll pass it to Yiman, who's going to talk about the fun fact and to conclude this video.
Next, we will explore the methods to make our own reusable cold and hot packs at home. First, we will start off with the cold pack. To make the Ziploc cold pack, the materials that we need together are Ziploc bags, water, and rubbing alcohol. The first step in the procedure is to fill a Ziploc bag with water and rubbing alcohol. The water to rubbing alcohol ratio should be 2 to 1, and the Ziploc bag should only be about 3/4 full. If you do not have rubbing alcohol, it can be substituted with corn syrup. And the second step is to remove as much air as possible from the Ziploc bag before carefully sealing it. To prevent any leakage, the liquid-filled Ziploc bag is sealed in another second Ziploc bag. And lastly, the Ziploc bag is placed and settled in a freezer for a few hours or overnight before use. Due to the different freezing points between water and rubbing alcohol, also known as isopropyl alcohol, we will get a gel ice pack instead of a hard solid ice pack. Next, we will proceed with the heat pack. To make the rice hot pack, the materials that we need to prepare are a pouch, uncooked rice, and a sewing kit. The first step in the procedure is to select a pouch for the hot pack. The pouch can be anything as long as all of its sides are sealed with only one opening left. And some examples are an old clean sock or a small pillowcase. The second step is to fill the pouch with uncooked rice. It is important to note that the pouch should only be 3/4 full so that there is space for the rice filling to disperse evenly when applied. The third step in making the homemade hot pack is to sew up the opening of the pouch. If you do not have a sewing kit, tying a knot at the opening of the pouch can also be an option, as long as the rice does not slip out. And finally, place the pouch in a microwave and heat it up for approximately 1.5 to 2 minutes, and the rice hot pack is ready to be used. Instead of microwaving it, we can also use the rice pack as the rice cold pack by placing it in a freezer for a few hours or until it is chilled. Before we end our presentation here, I would like to provide a brief conclusion to sum up what we have presented and what we have learned as we work on the slides. In our presentation, we have covered the basic information, applications, as well as fun facts about hot and cold packs. Throughout the process of making the slides, we managed to gain a better understanding of the thermochemistry of instant cold and hot packs. And we also notice and understand the importance of teamwork. That's all for our presentation. Thank you.
First and foremost, I would like to thank Ms. Mashinda for giving us this opportunity by bringing us together for this assignment and guiding us throughout this assignment.
We would also like to thank Ms. for your tremendous support and encouragement that you have given us throughout our PBL. We would like to thank the time contribution of everyone for watching our video. I would like to thank each and everyone for encouraging and supporting to complete this PBL. I would like to thank each and everyone for those in this group that has given full cooperation to complete this PBL. We would also like to thank the Quest Library for providing us a group to finish our discussion without any interruption.
And I would like to thank my family members for their